Ever looked at a chart and thought, wow, I wish my data could look that good? With Matplotlib and Seaborn, it can. These libraries let you take raw numbers and transform them into visual stories that grab attention and make an impact. Welcome to Day 3 of the 30 Days of Machine Learning series. If you're new here, don't worry. You can find the full playlist right here and jump in at any point. And hey, don't forget to hit that subscribe button so you never miss an update. In this video, we'll explore how customizing visualizations with Matplotlib and Seaborn can make your data stand out. From adjusting colors and styles to creating polished professional charts, you'll see how simple tweaks can transform your visualizations. Stick around, and let's make your data not just informative but unforgettable. We will load in the CSV file, named historicalprices.csv using the pandas library, and view the first rows using the .head method. As a quick cleanup step, we will also need to use the rename method in pandas, as the dataset we downloaded has an extra space in the column names. We will also ensure that the date variable is a datetime variable and sort in ascending order by the date. Next, we will load the PyPlot submodule of Matplotlib so that we can draw our plots. We can create a line plot in Matplotlib using the plt.plot method. We will visualize the close price over time of the DJIA. We can visualize multiple lines on the same plot by adding another PLT plot call before the PLT show function. If we want to distinguish which line represents which column, we can add a legend. We can do this using PLT legend and adding label parameters to each PLT plot call. For this section, we will aggregate the data into monthly averages using pandas so that we can compare monthly performance during 2024 for the DJIA. We will start by creating a bar chart with vertical bars. This can be done using the PLT bar method. Similar to the other plots, a scatter plot can be created using PyPlot scatter. Next, we will add a trend line to the graph to show the linear relationship between the open and close variables more explicitly. The first method will give us a least squares polynomial fit, while the second method will give us a one-dimensional polynomial class that we can use to create a trend line using PLT plot. For a line plot, we can change a color using the color attribute in PLT plot. Below, we change the color of our open price line to black and our close price line to red. We use a color map by passing the close price, Y variable, to the C attribute and the plasma color map through CMap. Finally, we can save plots that we create in Matplotlib using the plt.savefig method. Now that we've covered Matplotlib, let's bring in Seaborn, the library that makes your plots not just functional, but beautiful. One of the most common datasets that's also used in all the official examples of Seaborn is called TIPS dataset. In Seaborn, scatter plots can be created using the scatterplot function. the plot can be customized with different colors and markers to help distinguish different groups of data points. This simple plot can be improved by customizing the hue and size parameters of the plot. Line plots are used to visualize trends in data over time or other continuous variables. In a line plot, each data point is connected by a line, creating a smooth curve. In Seaborn, line plots can be created using the line plot function. We can very easily customize this by using event and region columns from the dataset. Bar plots are used to visualize the relationship between a categorical variable and a continuous variable. In Seaborn, bar plots can be created using the bar plot function. Let's customize this plot by including sex column from the dataset. Histograms visualize the distribution of a continuous variable. In a histogram, the data is divided into bins, and the height of each bin represents the frequency or count of data points within that bin. In Seaborn, histograms can be created using the Hist Plot function. Density plots, also known as kernel density plots, are a type of data visualization that display the distribution of a continuous variable. They are similar to histograms, but instead of representing the data as bars, density plots use a smooth curve to estimate the density of the data. Box plots are a type of visualization that shows the distribution of a dataset. They are commonly used to compare the distribution of one or more variables across different categories. Customizing the box plot by including time column from the dataset. A violin plot is a type of data visualization that combines aspects of both box plots and density plots. A heat map is a graphical representation of data that uses colors to depict the value of a variable in a two-dimensional space. Heat maps are commonly used to visualize the correlation between different variables in a dataset. In this example, we are using the flights dataset from the Seaborn library. We pivot the data to make it suitable for heat map representation using the dot pivot method. Pair plots are a type of visualization in which multiple pairwise scatter plots are displayed in a matrix format. We can customize this plot by using hue and diag kind parameter. Joint plot is a powerful visualization technique in Seaborn that combines two different plots in one visualization. Adding annotations can help to make your visualizations easier to read. We've shown an example of how to add them below. And that's a wrap on Matplotlib and Seaborn. Today, you discovered how to transform raw data into stunning, customizable visualizations that not only inform, but impress. But hold on, because the journey doesn't stop here. In the next video, we're diving into the world of scikit-learn. From pre-processing your data to building predictive models, it's where the magic of machine learning truly begins. So hit that subscribe button and get ready for day 4. It's going to be a game changer. See you there.